In this video, we're going to learn another type of calculation that can be used with electrical circuits, specifically focusing on electrical power. Now, in the previous video, when we talked about Ohm's law, I kind of quickly defined voltage as the amount of power that can be generated by a power supply within an electrical circuit. Now, this definition is not exactly correct for one simple reason. If we consider the power supply, and let's even define each of our batteries as having a specific 1.5 volts each. The problem is, if we take these batteries out of the electrical circuit, do they generate any power at all? Well, the answer to that is obviously no, because the power supply needs to be connected to electrical wires to transport electrons from the anode to the load within our circuit, and the current needs to go completely around the circuit in order to generate power. Simply put, electrical power does not exist unless the power supply is specifically connected to an electrical circuit. Otherwise, there won't be any current generated. Therefore, we can define electrical power as the voltage supplied by the power supply multiplied by the strength of the current that is created within the electrical circuit. And the unit that is given to voltage multiplied by current is the watt. And watts is the plural form named after James Watt, the physicist that first described it. Now, because we have defined the voltage of each of these batteries here as 1.5 volts, and if we measure that this creates a current of 4 amps, we can fairly simply calculate what the what the electrical power of this circuit is going to be. So if we take our voltage of one battery and multiply it by 3, because there are 3 batteries, we find the total voltage is 4.5 volts, which we can then put into our formula for electrical power and do 4.5 volts times the 4 amperes that we found for our current. And if you put this into your calculator, it comes out to exactly 18 watts, the short form for which is the uppercase W. Now, this calculation is very useful because we can use this in order to calculate the amount of power required to power electrical devices, such as the stylus that I'm using to write this, or even find out the amount of power produced by power generating stations. The problem is that if we look at this measurement, even though we see the word watt there, we see that they are also preceded by prefixes. These are numerical prefixes, and even if you've never seen the word megawatt or milliwatt before, you can quickly figure out what they mean if you can think of similar words that use these prefixes. For example, we know that a kilometer, which we represent by km if we were measuring distance, is 1,000 meters. So naturally, a kilowatt is also going to be 1,000 watts. We can shorten this by saying that it is 10 to the 3 watts. Again, the exponent 3 simply representing the number of zeros that we have here, and the short form for kilowatt would be kW, in the same way that kilometers would be km. If you know anything about computers, specifically memory and hard drive space, you'll recognize the term megabyte, represented by the uppercase M, and because we're talking about megawatts, this would be uppercase MW. Now, a megabyte that measures computer memory means that you have 1 million, so that's 1 with 6 zeros here, 1 million bytes of computer memory. So a megawatt is going to be 1 million watts, which we can shorten to 10 to the 6 watts like this. So using this measurement here, we can actually convert megawatts into watts using a fairly simple method of calculation. So if we take our starting measurement, 1300 megawatts. Now what we want to do is we want to convert this to watts. So what I'm going to do is multiply this by a fraction that we call a conversion factor. So a conversion factor is a number that is always equal to 1, and the unit that we want to cancel megawatts and replace it with watts. So what I'm going to do is I'm going to put megawatts on the bottom here, and we know that 1 megawatt is equal to 10 to the 6 watts, like this. So here we can see megawatts is multiplied on top, and then we see that it is divided here, which means that this unit cancels itself out like that, leaving watts like this. And again, whenever we multiply 10 to any exponent, all that we need to do is add this number of zeros to the number. So this would be 1300, and then all we need to do is add 6 more zeros, and there is our conversion in watts. Now for prefixes like milli or centi, these are a little bit more tricky, because if you remember the term millimeter, a millimeter is 1,000th of a meter, meaning that a meter can be broken down into 1,000 equal pieces, and those are millimeters. So the symbol for this would be little mw, and instead of being 1,000 watts, this would be 1 over 1,000 watts, which we can represent by the short form 10 to the negative 3 watts. The negative simply means 1 over that number. So because 1,000 is 10 to the 3, this would be 1 over 1,000 instead. Likewise, a centiwatt, symbol little cw, we know that a centimeter is 1/100th of a meter, so a centiwatt would be 1/100th of a watt, or 10 to the negative 2 watts. So if we wanted to convert this measurement here into watts from milliwatts, again, we would start with our number 5 milliwatts, and then if we remember our conversion factor that we have here, the unit that we want to get rid of is milliwatts, so that would go on the bottom here, and the unit that we want to replace it with, watts, goes on top here, and we know that 1 watt is equal to 1,000 milliwatts, so all that we need to do is 5 divided by 1,000, which comes to exactly 0.005 watts. This conversion here, the bottom question, is a little bit tricky because we have one extra step here, but in terms of the unit conversion, it's relatively straightforward, so I'll leave this challenge to you to try out. For now, the last calculation that we're going to explore how to do is measuring something that we call kilowatt hours. So kilowatt, again, meaning that we have 1,000 watts represented by kW. Kilowatt hours are a very important measurement because this is how electricity bills for household and business uses are calculated. And if we look at the units for kilowatt hours, kWh, it basically tells you everything that you need to know to calculate what a kilowatt hour is. So the first thing that we need to do is find the number of watts of power that a device uses. So in this case, we're looking at a hairdryer. So if we have 1,500 watts, then we need to find out how many kilowatts that is. So here is our conversion factor. Again, we know that 1 kilowatt is equal to 1,000 watts. So if we do 1,500 divided by 1,000, this comes to 1.5 kilowatts, and then all that we need to do to find kilowatt hours is take our kilowatts and multiply by the total number of hours that the electrical device is used for. This is the one confusing part right here, because whenever we think of time, usually we divide our measurement by time, for example, for finding kilometers per hour, but here we're actually multiplying by time, because you're taking this unit of power and multiplying it by the number of hours that you use it for, which in this case is 3. And even without a calculator, we can do 1.5 times 3 comes to 4.5 kilowatt hours that were used in order to power this hairdryer for 3 straight hours. Now that you've learned how to calculate kilowatt hours, if you take a look at some of the practice problems below, these will give you practice with converting between watts and kilowatts, then calculating kilowatt hours using the time that is indicated here, and then using another calculation with the electricity rate. So for example, 15 cents per kilowatt hour, you can actually calculate somewhat realistically how much it costs to operate electrical devices. So if you're comfortable with calculating kilowatt hours, try a few of the practice problems listed below.